length of the thread oscillation, that is called time period of the pendulum. This capital L is the length of the thread plus radius of the bob. This capital L, this is called effective length of pendulum. And G we know, small g, this is acceleration due to gravity, which is 9.8 meter per second square. So from this equation we can say that the time period of a pendulum is directly proportional with the root over of the effective length of the pendulum. So if we square both the sides, then we can have t square is proportional to L. For this much length of the pendulum, let us see the time taken by this pendulum to complete 10 oscillations. Let us start now. Start the stopwatch. 1, 2. Stop. So we can see the time taken for the first reading for 10 oscillations by the pendulum is 18 seconds. We have shortened the length of the pendulum. Now let us see the time taken by the pendulum for 10 oscillations. Let us start the stopwatch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can see for the first set of reading, when the effective length is 72.8 centimeter, the time taken for 10 oscillation is 18 seconds. And when the length is 43.1 centimeter, then the time for 10 oscillation is 13 seconds. So we can see that when the length is greater, time taken for 10 oscillation is greater. And when we are decreasing the length, the time for 10 oscillation is also decreasing.